All right, so today we're going to start and talk about horizontals and heads. And when I say heads, I'm just talking about the soffit, under the soffit heads, which are typically under strip window or for strip windows. We'll do a whole separate section on stack joints and parapet heads as a separate thing because those have their own things to worry about. And the reason these are kind of similar and that it makes sense to do these together is that the logic is pretty close to the same, even though the shape of the parts are slightly different. And then the head does have their own nuances, which I'll go over. But the most basics are the horizontals. So we'll go over that first. So obviously you have the two different most common, captured and inviso. Our standard is 2.5, even though our verticals are 2 3/4. I'm thinking in the new next gen, I think it's all going to be 2 3/4 is my understanding, but I'm not 100% sure. The reason for this height though is because we don't need the extra glass bites. So usually the reason for a taller horizontal member is so that you get the proper bites. Or if the architect just wants a certain look. So that's usually what drives it. So 2.5 gives us the adequate bite we need. So that's why we're keeping it. And also that's what our original all wall was made. It was a 2.5-inch system. And again, I think it was more of us just, if it ain't broke, don't fix it kind of logic. When we went to the W75, like 2.5 works. And I think we were also concerned that the customers still wanted the smaller profiles because that's what they wanted in the past. So we thought that they would prefer the 2.5 and not have to have a 2 3/4 when we didn't need it design wise. So I think that was the logic behind it. Okay, so then so for the captured, we'll just break it down. Typical assembly screws are 3 per each end. And we use these 3 for, I guess, again, I don't remember there's a terminology, I think, for the offsetting of the balance, because all the weight is up here. Yeah. So you would think that you would put the screws here.
Yeah, I remember asking that question before.
Yeah, and I forget I think there's a term, I can't remember the term offhand, but there's a reason why I think it just offsets it. I'm sorry, I don't remember the terminology, but there is a reason why I think this one is used instead of this one. And I think it's to counter the weight so that it doesn't want to over rotate. I think that's part of it. I'm sorry I don't have all the terms.
You're fine.
But there is a reason for that. But again, in some extreme cases, if the glass is really heavy or large in certain places, we will use the 4th screw. But again, that's very rare. And then if you do see the taller profiles, also that's where you may see 4 screws. But our standard is 3. Then you have the Isobars. I didn't really cover that in the other training, but that's just to split for the thermal. Basically, it's a hard plastic and it splits the metal that's exposed to the weather to the metal that's on the inside so that this metal here that like a person can touch from the inside, it won't be as affected by if it's hot or cold outside. So that's what the thermal breaks are for. And that's what these are doing here. But even though they're splitting up the 2 aluminum pieces, our vendor will crimp these 2 little legs down and basically like pinch it, and that's what holds them in place. So then even though these are drawn as separate entities, these really are one extrusion. So we get all of this as one piece from our extruder. But the dies are calling this part of the body an A and this part of the body a B. And then they put the 2 together to make this one extrusion for us. So that even though it's drawn this way, that's how it's made. Okay. And then you have the face cover. So this also has different terminologies. Excuse me. Some people call it the face stop. Some call it the rockin' stop, face stop. Some call it a cover, captured face. So those all referring to the same one piece. So the way this is installed though, it does rock on. So if I just kind of rotate it, Oh, my ortho again. So if I just kind of, so it does kind of rotate like from this way in, and then it kind of wedges itself in when they put the gaskets in place.
Oh, okay.
So that's why some people call it a rock-on stop.
Oh, I've never
So
heard
it's
of that.
kind of like that. And then once it hits that leg, it bottoms out, and then they wedge in the gasket, and that puts pressure.
Oh, okay.
And then that's what wedges it. And you see that's what this leg is for, to stop it. And then that's why this is pressed furthest against this edge, because the pressure of this gasket is pushing it outwards. And that's why these are wedge gaskets. They physically get wedged in. So again, let me just move this one out. So now my F8 is not working. It freezes my CAD. So now I have to type.
Oh, I hate that.
Yeah.
Drives me nuts.
I have to type it every time.
I was wondering why you're typing.
Okay, so if I move that out, so literally this gets wedged in like this, and it gets pushed down. And that's why it's called a wedge gasket. Whereas this one, it has a dart. These get pushed in from the front this way. So they're actually installed differently because they're serving a different purpose. So this one being installed from left to right.
And that's installed before the glass?
Yes, that's installed first, and it's basically acting as a spacer. So this gasket's much more dense than this gasket. And so this one's acting as a spacer. So that way, when they lay this piece of glass on it, it doesn't collapse. And again, you got to imagine this is actually laying on the table this way for the shop. Right? So it's laying down, facing up on the table. And so gravity is pulling everything down. So they have to put that wedge gasket or this dart gasket in, and it acts as a cushion. Does that make sense?
Yes.
Okay. So those are denser than these. And then once they lay the glass,
sorry, I didn't hear that.
It's more dense.
Oh.
So like if you squeezed it with your fingers, like it would be much harder than this one. And then this one is softer so that they can push it in, and it'll kind of squish a little bit until this dart engages in the pocket. And then that's what's holding it in place.
Oh, okay.
So that's what the wedge gaskets are. So you have that on top and bottom. So again, you literally have pressure holding this piece in place. That's why we don't fasten it. It's just pressure from the gaskets.
Okay.
Okay. And then you have the setting block. So again, we show it here. It's only 2 per light. So every piece of glass has 2 of these. Okay.
Where do they sit usually?
Yeah, they're usually at the quarter points.
Oh,
so
okay. Is that what that note means when you when I see like is it the setting chair? It's like quarter.
Yeah.
Okay.
Yeah, so if I took this, if this is my elevation and I cut it in half, and then I cut it again in half, this point is a quarter point.
Oh, okay.
Right, so you're just cutting the opening in half and then half again.
Oh, okay.
So if this was my one opening, so if this was 5 feet wide, we would put a setting block there and there.
Okay.
Right, so quarter points. So there's only 2, and never have I don't think you ever need more than 2. But we're finding that the lengths have to vary based on the size of glass. So that's just a mathematical calculation having to do with movement. So kind of getting a little deeper, but imagine in an earthquake, if this is the piece of glass, it's going to want to pivot. Right. And you don't want the lowest corner to hit the horizontal, right? Anytime if glass hits the metal, it's just going to break.
Shatter.
So the longer we put a setting block here.
Oh, it kind of helps stop it.
It gives it a bigger surface area so that its pivot point won't be so low.
Oh, okay.
You know, I'm trying to explain it, but like it'll hit that block before the bottom part hits any metal. So so usually the larger pieces of glass need more setting block, and I think it also has to do with the weight. I'm not 100% sure, but because of the size of the glass, it's heavier, and so I think the larger setting blocks help with the weight distribution as well. I believe that's true. I'm not 100% sure, but I believe that's true as well. So so that's why the setting blocks, we usually call them out at quarter points. And then that's why sometimes you'll need some that are 4 inches, some that are 6 inches, 8 inches, and sometimes all the way up to 10 inches long, just depending on the size of glass.
How come we don't add that call out here in like our detail views?
Because it's kind of a known thing. And we call it out on the general notes.
Oh, okay. So that known.
Yeah, that is cut 4 inches at quarter points is our standard note on the general notes page. And then that's why on the elevations, though, when the drafters do need something bigger, let's say they do have a big piece of glass, they're adding a special note on their elevations, because it's really only
special what?
A special note to let the fab team know, like, hey, on this particular light, I need a 6-inch setting block, but everywhere else is 4, because our standard is 4 inches. So only special cases are when we need the larger setting blocks. And so the way the drafters are handling that is by showing it on their elevations. And I believe they're using a little symbol.
Okay. Makes sense.
Okay. And then we have our famous little notch. So we don't have it in our installation manual shown. That's something that's missing. But this notch is for weepage. Okay, so water is technically allowed. We're allowing water to come in this front area. Again, we're not like making it. We're just anticipating water could get in there. And if it does get in there, it needs a way to get out. Okay, so we notch this at captured only. So that way it gives them space for water just to drain out if any water did get in there, without it ever piling up and possibly getting on top of the glass. Because if water gets on top of the glass, you know, more than likely it's going to trickle in, and then that'll be a leak. So by giving air and water a big space in here, the thought is, the design is, if water does get in there, it'll just flow right out because it has a lot of air and space. And then the reason it's only at captured, I believe, is because it has something to do with also installation. Again, Tony explained it to me, but now I can't remember. This also allows them ease of installation of this cover as well at the captured, because again, if you remember, we try to cut it tight. We cut the covers tight. So again, and it rocks on, so it's just allowing them more space to get it on. Again, I'm sorry, I should have prepared a little better. I forget there was a better reason for this notch as well. So it's weepage, and then I believe it helps with installation as well of this cover.
Okay.
But again, I'm sorry, I gotta get more
explanation
on that. But there is more reasons behind it. So again, and I think Tony gave me a nice explanation. I just forget. Right now.
Yeah, honestly, I never even knew what it was for. I just know it was standard to put it there.
Yeah, but see, it's good for us to know, right? So we can understand it. But so main thing is weepage, and then I believe there's some reason it helps with install as well. Okay, and then this sealant here is our assembly seal. So again, anytime metal and metal come together, we have to seal it. So we represent it like this in our drawings, and it's really a big slather of sealant that the shop puts on.
Right.
Just to ensure, again, just in case, again, we don't want any water in there. But again, if by chance some water does get in there, we want to put up a wall so that it doesn't go any further. Okay, so then that's the horizontal captured. In Viso, everything's the same. Like I said, just no captured face. So these have some of its own little components here.
Oh, that was the note I was talking about right there.
Okay, yeah. So this metal piece is the setting chair. And so it is literally just to support the setting block. So as we found out, right, setting blocks only occur at quarter points. So that means this only also needs to occur at quarter points. So it's not continuous. It only is the same size as the clips. I mean, as the setting blocks, and it's at the same location. So again, those chairs only occur here and here.
Got it.
Okay, and then the setting block, again, is serving the same purpose. It's just for the glass to sit on. And we only put a setting block, you know, on the glass bottom. And then there's no setting block required here at the top of a glass because it's sitting on the bottom down below, right? So setting blocks only are required at the bottoms. So sometimes that's a drafting error. Sometimes I see it, beginner drafters, they just mirror stuff and then they mirror the blocks too. Sometimes that happens at heads, they mirror blocks, you know, so it's just kind of remembering you only need it here.
Right.
So it's just, that's just drafting mistake. They just mirror, and they don't fix it.
Don't mirror.
Yeah.
I learned that quick.
Yeah, because it's just not that simple. It's even though it's just a nice rectangle. Yeah, there's more stuff to it. Yeah.
So is Inviso, is it okay to get water?
No, so we're not anticipating any water here. So they still put the assembly sealant. We just don't show it because it would just be all overlapping. Yeah, but any metal to metal, they put assembly sealant. But again, at Inviso, instead of a gasket here, we have actually sealant.
Right.
But we're not anticipating any water getting past this line. It can't, because if it does, then that's a leak, because then technically it's on top of glass and that'll just trickle in.
Okay.
So Inviso is a little bit more water friendly, I guess, per se, because it's all sealed up. And so sealant is a much better barrier than gasket, because gasket still can have cracks, right? Or can have little gaps by accident, right? Or be cut too short, or, you know, there's a little bit more human mistake in gaskets, whereas sealant is just a dam, basically. And so it's much more secure.
Okay.
Yeah, so we're not anticipating any water getting through this at all. And then this setting chair also just rocks into place. So that's why, again, no fasteners. It just basically wedges itself in. And then again, the weight of the glass is holding it in place. So it's putting pressure, you know, weight is sitting on it. And so that's what's putting the pressure, and the leg. That's why we have this leg here to keep it from over rotating, and this big leg up here.
Okay.
Okay, so this one, again, that's the correct orientation. If by accident, some people might think, oh, just flip it, again, mirror it, that won't work. Okay, so yeah, so there's a reason, again, for design. So again, we're imagining the weight is being put on this leg, pushing down on it, which is wedging itself in on the horizontal piece. Does that make sense?
Yep.
Okay. All right, so that's a horizontal, and they just butt up to daylight. And the only, like I said, tricky thing is the cover, which we talked about last time, was that it stops on 16th short of a captured face on the left side only. And again, that's for installation purposes. So that's pretty much horizontals. I just wanted to show you, because I wasn't going to model it. Let's see if I got bookmarks here. In our installation manual, our current one. So if you kind of want to see a little bit more graphically how things go together, again, Mike helped me put these together, but it may help you just to see a little bit more, you know, with the gaskets installed, how they're screwed in, you know, that you see the assembly screws, the access holes, you know, those kind of things. So these are kind of nice, and they're here for the horizontals. We do have these drawn. And then also seeing the glass. See, and then there's the setting chair and the block. So he actually modeled those. So it just kind of gives you a little bit more of a visual of what those are, and then, you know, the finished sealant there. So just kind of putting that out there, that our manual has these conditions captured and Inviso. Like I said, he's just missing the notch part. So because that's at first what I was looking to see if he explained it, but he didn't. But you know, you can see how the pieces actually go together. And then there's the assembly sealant there. So just kind of reminding you, it's there, the manual currently, and it's in the 56 series are for horizontals. And then we'll get to the heads next. All right, so for heads, so again, these are at a soffit condition. So basically more of a strip window. So the one thing to remember here, so I'm just going to make that. So now that we're looking at the heads, we'll just draw, so focusing up here. So these heads have the mini Mac, that we call it. Oh, there, my F8 worked. Has this mini Mac. Okay, so do you recall, is this a wind load or a dead load condition anchor?
What was that?
Do you recall, is this a wind load or a dead load?
The 3604? Or just the...
This head anchor in general. Just looking at it, is this a wind load or a dead load?
Hold on, let me think here. This is a wind load.
Yes.
Okay.
Okay, so that means we are allowing this horizontal or head member or the whole unit to move up and down.
Right.
Along that mini Mac. So that mini Mac is keeping it in from left to right. See, so it can't fall out, but the system is allowed to move up and down.
Right.
Okay, so that is a wind load. And again, the little caveat or a little trick of knowing that it's a wind load too is that there's no attachment at all. So you could see the top of the vertical stops at the top of the head member. There's no fasteners or any type of bolt or anything connecting that vertical to the structure.
Right.
So that's another little sign that this is a wind load. So it's just kind of a loose notch. So this is the notch we have. So again, what are we notching here?
Just so that mini Mac can sit there and allow for up and down movement.
Right. So we're notching the head member, not the vertical. Yeah. So just because some people get confused that these mini Macs go inside the verticals, but they don't. So again, this is where we have a nice picture. 61. So here's our picture. So that notch is way over here in the head member itself. So you see the head member is kind of laying down. So that notch is like right way over here.
Okay.
And that mini Mac fits inside that. So it has not, again, so even though our detail, it's all squished.
Right.
Just have to remember, again, we're showing something flat that's really stretched out at least 6 inches or more. So those mini Macs, even though it may kind of look like it's inside a vertical, it's not. It's way over here at the heads. And then there's one on each side. So each unit has 2 of them. So just like we had the setting blocks, now mini Macs, there's also one there and one there. Okay. So if that's a wind load, that means your sill of the unit has to be a dead load.
Correct.
Okay, so that's just one thing I always check is if this detail is ever used at the head of something, I always check the sill of that unit to make sure it's showing a dead load.
Right.
So especially that usually gets missed on curtain walls because they just copy the same typical stack joint detail, which is always a wind load. So that's when they should be using the 1A stack joint detail that shows the dead load.
Right. Okay.
So that's one of my checks because if this happens at a strip window, it's kind of automatic because our strip window is always a dead load sill. So that's easy. But when it's a curtain wall, our stacks are usually wind load. So they have to make it call that out as a dead load in order for it to work. Or they have to change this anchor to be a dead load instead.
Okay.
So that's a typical error that I see a lot from Jumpstart just because they're not looking at the whole elevations. They're just looking at the, oh, I have a captured head soffit. Let me use this detail, you know, and they're not considering that part of it sometimes. So it's just a good double check. So that's just something I look out for, especially on curtain walls. Okay, and then we have all these other hidden lines. and such. So again, we're looking at something squished. And then the reason these are hidden is because those are actually inside the verticals.
Mhm.
Okay, so these two items are actually plugs inside. Let me see if he shows it on here. I don't think he does. Oh, yes, he does.
Nice.
Oops. What happened? Okay. Oh, that's why. Okay, so that plug is right there.
Mm-hmm.
So that's what we're calling the 42C. So here's that hidden line here. And so he's missing the other one. So we started putting another one in this cavity. Well, oh, he's an Inviso, sorry. He doesn't have it captured.
Yeah, but in the captured, it's down further, right?
Well, in the captured, we have an extra cavity of the pocket.
Yeah.
I'll show you in our detail here. So we have this cavity here.
Yeah.
So we would need that 42C here and here. Mm-hmm.
Right.
Right. So that's why on that detail, we show the 42C in two places. And that's why we put the at captured vertical pockets where occur.
Right.
Because at an Inviso vertical, we don't have that pocket like we saw.
Mm-hmm.
So, so that's another good little check. If the job, let's say this project is all Inviso verticals and only captured head, then that means we can technically remove that.
Oh, okay, but then that would change the family, so it'd be a new family.
No, I mean, I'm just saying technically, because we put this as captured, so we don't have to.
Oh, okay.
But I'm just saying to be correct, technically we won't need that on an all Inviso vertical job.
Oh, okay. Yeah.
Right. So just again, understanding why we have this note and then when we need each. Okay. And then why we show it this way. So right now we show it because in this one, we're showing a captured vertical because I have a line here. So that's how I know this is a captured vertical beyond. That's what we're showing.
Okay.
Okay. And then we have this extra splice sleeve. Mm-hmm. Okay, so again, just remember you have two units coming together. So again, anytime you have two units coming together, you have to splice them somehow. So that way we don't have a gap or we don't have a hole. So that's what this is. And again, so that's happening beyond, and that's happening at the center of the mullion where two units are coming together. And let me see if I don't think he shows it. Nope, I had an ISO of it. Shoot. It's going to be similar. Let's see. Okay, here, it'll be similar to this. So, so you can see you have two units coming together. So there's the 42Cs all shown there. And then this black is that silicone sleeve that we're showing in that detail. Okay, so that is a silicone, again, if you remember, is the Dow 123. It's like a thick rubber band, right? And big, and it's already pre-cut. So that's why we have to give it a size. And then you have to, they just literally, again, squish it on top of the unit right there. And then totally seal that whole thing in place.
Give a water barrier.
Yes, exactly. So again, you have when two units come together, because you see you have all these kind of holes. And you don't want any water getting in there. So that's what this whole thing is to cover. So that's why we have that 08D. Right. And so some people were asking, you know, the size and all this stuff. So if I remember, I discussed this with Bob a long time ago when I created that first sheet. And he said that, you know, bigger is a little bit better. So that way they have more to play with in the field. Yeah. So that's why it goes all the way back here. So right now, technically, this model is not fully correct because really it goes further back.
To like the,
It goes, because he also wanted to cover those two holes as well, because that's all the wet area. Right. So if I made it any shorter, there's a possibility that water could get in there, which we don't.
Didn't you have Daryl make that one sheet with all the covers on all the different conditions?
Say it again.
Didn't you have Daryl make that one sheet with all the cover, like different size conditions?
That was for this condition of this actual, this is the parapet detail that we're looking at. And that's what he was drawing was this plate.
Oh, yeah, the plate.
Yeah,
Okay.
so that's another thing, but that happens at the parapets. This is at, I'm just using this as a reference because I don't have an ISO of the other one.
Oh, okay.
But it's similar, just at the soffit, at this condition, we don't put that plate. Because the field doesn't have access to do any of that work. Because imagine there's stud framing or something here, structure.
Yeah.
The field has no access to do any of that work.
Okay.
At a soffit condition, but at a parapet, they do.
Got it.
Yeah, so that's a separate thing. So when we get to parapets, we'll go over that. So that's why we showed this going from front all the way to the back. And then this little squiggle, I mean, again, we could technically get rid of that squiggle. That's supposed to represent sealant, which technically we can get over that. But it's just bed and sealant, and the field just plops it down. So the only thing to be careful of for that sizing of this is if you have wider mullions. So if you remember on this, an 08D has a certain size, and it's cut to be for a 2 3/4 mullion. So if a job has a 3-inch vertical or a 4-inch vertical, we're going to need to change that 08D to something else, because otherwise it'll be too small.
Okay.
Does that make sense? So again, even though it's on a horizontal or a head detail, the verticals affect what's happening here. So we just have to, that's another little check. So again, if you see you have wider mullions, that's one thing we have to check. And that's true also for the stack joint splice sleeves. I think we cut those at 4.5 long. So if there's anything wider than that, we need to check the widths of these sleeves. Okay, and then this guy is our new design, fairly new design of having this double kind of big hook. So again, this is a field applied. So do you know why it's field applied?
So they have access to attach that mat clip?
Correct. Yes. So again, that you saw that big, let's just, I should pull it in. Yes. So just so we all have all on the same page. W75, 36. Okay, so this is the shape of the Mac clip, or mini Mac. And we're in this detail, right? We're looking at it
from the side
this way, right? Right. Okay, so the way, if you remember the notch in the head, let's just say the notch is this big. Okay, so the field, my understanding is the shop lays this down on top of the head member. Well, shoot, I don't know if they do. I think they do. I think they lay it there, and I think they put like a tape or something so that it goes. So yeah, so that it goes with the unit, and it's in place already, so that the field doesn't have to go look for it. Okay.
And all they have to do is like untape it and attach it.
Yeah. So then they have to, once they put the unit in, yeah, they untape it, and then again, so now the field is installing from this way underneath. So they need access to get up underneath this thing to push, not only push it up in place, but then to fasten it also. Right? Because so they have to get their drill bits in there from underneath to fasten this thing in place. So in order to do that, they have to have this open cavity. Does that make sense?
Yes.
Okay, so then after they install it, then they put this back, and that's how they know, okay, my head is done. And so that's why this is field applied.
Right. Okay.
Okay, so then what gets tricky though is when we have back pans and shadow boxes, because normally that's all done in the shop. And I still, I still don't know what our plan is for that, what we've been doing, because it's been a question I've had on so many standard library details. And they've been saying the shop would apply, but then that would mean we have to change this anchor because then the field doesn't have access. But I haven't seen that fully drawn out on any job. So I'm not sure exactly still what the field has been doing in that case, if they have been installing the shadow boxes and stuff at these locations, which I don't think they have, but I don't know myself what they've been doing when that happens.
Okay.
So that's just one of those kind of things. If you see a shadow box or a back pan on a head like this with a mini Mac, that's a question. It's just, how are we doing it? Is the field installing it? Is checking, does this say field or shop? And then even if it says shop, it's still going to be, well, then how's the field going to install the unit? Because they won't have access to this mini Mac. So then this anchor would have to change. So something would have to change if you have a shadow box or mini Mac at these kind of heads.
Right. Okay.
So it's just another little thing to kind of look out for, or at least ask the question, because something won't work. Okay, and then now in Viso, same logic of everything else. The only difference is, again, you don't have a captured face, but instead now you have this little thing to worry about, this trim. Right. So again, this also has different names. Some call it Inviso trim. Some call it an Inviso leg. Some call it, what do they call this thing? Flat plate. Huh?
Is it also called like a head trim?
Head trim, yeah, but see, this same part is used vertically. Yeah. So some call it the jam. Yeah, so it's a trim. Yeah, so this thing has a bunch of different names as well. But this is, again, a single piece, but it has the isobar, so that way, again, the heat, whatever, doesn't transfer. But you see this notch? Do you know what that notch is for?
Let me think here. Hold on. So vertical. Hold on. If I went to a vertical detail, let's see here. Is it to place it?
It's not to place it.
Okay, go ahead.
So let me. Oops. Okay, so imagine this guy is running across horizontally. Okay.
Okay.
Right, so kind of like how I did the sill, I'm projecting the lines. So if this continues, you see this part will hit the vertical. But I need this part to keep going because we treat it just like we treat these covers.
Oh, okay, so it's like a cover.
Yeah, so they extend and then they splice at the middle with a 16th gap. Okay, so I need this part, yeah, to keep going, but that part hits the vertical.
Okay.
So that's why this gets notched. So let me see if I have a Inviso.
That would make sense.
Oh, of course, this one doesn't have the trim, but it would run across to the midpoint of the mullion, and that part of the vertical, or that little part of that trim would hit the vertical. So that's why that's notched. So that's why the note says at vertical, I think over here.
Yeah.
Notch each ends at vert. Yeah, so whether it's an Inviso vertical or a captured vertical, this piece has to run to the middle. So again, because too, you think that little bit is visible. And so in your, finished view, you don't want to see it stopping here and have a big 2.5-inch gap where you don't see that little trim going all the way across. So we're trying to make that illusion that that little trim piece goes all the way through so that it gives the customer a nice, like, finished picture frame kind of line is usually what that's trying to do.
Okay.
But as you can see, sometimes we don't have it. You don't always need that little trim piece. Oops.
Okay. Got it.
Okay. And then the other thing is the gasket recently changed to 43. So I believe it's a longer gasket. And then I think the previous design had 3 holes in it.
Yeah, this one only has.
Yeah, and then this has this big void in it. So I believe, from my understanding, what Kendall said was that the field was having problems with the one that was one solid piece. Okay. I think it was quality issues from our vendor, I think. So by changing the design, I think this is easier for our vendor to make a better quality gasket. And that's why we changed it to this 43.
Okay.
So this should be the standard one we see at Inviso conditions, 43.
Right.
And then, oh yeah, and then sometimes the mini Mac, we have the longer one.
Mm-hmm.
So again, that is again based on the size of joint required. So like, where's the structure? If it's higher and we just can't reach it, or if this unit is expecting a lot more movement. So again, our typical allotment of movement is usually 3/4 of an inch. But again, at some extreme cases, sometimes the movement is really bad. And so we need to allow for more movement to happen. So if, let's say, the structure we're attaching to has a 1 inch tolerance, you know, if it goes up 1 inch,
Mm-hmm.
we want to make sure our unit doesn't fall out. So that's why we use the taller one at times. So again, so we have to just, whatever Jumpstart figured, because they should be calculating that, we have to make sure we use the right one in our details.
Okay.
But that's why we have the two different ones.
Got it.
Okay. All right, so that's heads and horizontals. Do you have any questions? I mean, everything, I wasn't going to model it because they're pretty self-explanatory. I think they just butt up. But do you have any questions?
No, it was good.
Okay, so what I was going to have you do for practice, if you have, because we're going to have a little bit of downtime coming up, I was going to have you practice modeling and just take our standard vertical and one of our standard horizontals and just see if you can model it.
Okay.
And I just thought that might be a good practice because then
like joining them together how they should.
Yeah.
Okay.
Yeah, and then any modification like that 1/16, or if you wanted to do the Inviso, like cutting this to the right size, you know, just kind of see if you could get it right.
Okay.
Just for practice. Because I said I did have that one cover for the UCI project that you could practice modeling too. So just thought that might be good practice for you.
Okay.
But any other questions?
No.
Okay. All right, so let me stop the recording. Oh,